In this section, we're going to discuss the migration phase. The migration phase is the phase where we migrate workloads from the on-premises environment to the cloud. We're going to start off with some considerations for the migrate phase, and then we'll take a look at what it takes to conduct a pilot. Thereafter, we're going to have a look at data migration, and we'll end the section with a discussion on application migration. During the migration phase, we need to consider carefully how the migration will be performed. We could, for example, decide to migrate our workload in a manual manner. While that may be suitable for a handful of applications, it may be infeasible where there are many applications and virtual machines that need to be migrated. Configuration tools take away a significant administrative burden. Container orchestration platforms such as Kubernetes are optimized for managing the lifecycle of workloads in a production environment at scale. It is also important to think about the deployment automation options that are available and select an approach that is suitable for the workload being migrated. Let's move on and explore the pilot phase. We're going to start off by discussing a number of considerations. Before embarking on the pilot, it is important to consider carefully what the objective of the pilot is. Is it, for example, a test run, or is it simply a proof of concept? When considering workloads for the pilot phase, it is recommended that you prioritize workloads that have a high value but low complexity. These workloads are of interest to key stakeholders. It is also recommended that you avoid critical workloads, as well as select workloads that have characteristics that can be identified within the majority of applications that have to be migrated to the cloud. Prioritize workloads that do not require any licensing in the cloud, and also make sure that any migration is not unidirectional. In other words, always ensure that there is the ability to roll back. Migration projects can be quite complex, so it is recommended that you structure the migration activity in a way that enables you to incrementally add value. In the pilot phase, when creating the foundation or the landing zone for the migrated workloads, it is important to consider separation of duties as a mechanism for minimizing risk. Also factor in the differences between the test environment where the proof of concept is being conducted and the environment where the workload will run while in production. And last but not least, it is usually necessary to configure networking in order to have access to the on-premises environment for the pilot. Let's explore some of the technologies, services, and platforms that you may need to align with services in the cloud during the pilot phase. During the pilot phase, you may need to consider how physical and virtual hardware in the source environment maps to virtual machines in the cloud. Another consideration is how storage services in the on-premises environment map to services such as persistent disks and object storage in the cloud. There are also many network services in the cloud, for example, content distribution networks, DNS, load balancers, and the mapping of these services to services in the source environment also needs to be considered. Consider how security services in the source environment map to security services in the cloud, for example, firewall rules, identity-aware proxies, SSL configurations, etc. Also consider how a directory service, for example, Active Directory in a source environment, maps to an identity service in the cloud. And last but not least, you may also want to consider how CI/CD tools in the source environment map to infrastructure and CI/CD tools and capabilities in the cloud. We're now going to move on and explore data migration. Let's explore data migration mapping. It is worth considering options for migrating data from the source environment to an object storage service in the cloud. Also consider services which are designed for transferring huge volumes of data, for example, a data transfer appliance. And many cloud providers now offer database migration services that enables databases to be migrated across environments. And don't forget to consider how files will be migrated to the cloud, for example, from a source environment to a persistent disk in the cloud. Let's explore some of the storage transfer services options. Most cloud providers provide a range of options for importing data into object storage. They also enable data to be easily moved from one object storage bucket or container to another and support HTTP endpoints. Many support a programmatic data transfer mechanism using a software development kit, as well as enabling users to transfer data on demand or on a scheduled basis. There are numerous ways in which data transfer can be optimized for speed. For example, decreasing the size of data through compression or deduplication can significantly improve performance. For a large number of smaller files that need to be transferred, some cloud platforms offer optimizations where the files are grouped together, compressed, and then transferred in one go. Where there is a need to transfer a huge volume of data, for example, terabytes or petabytes of data, it is strongly recommended that a transfer appliance is used instead of transferring data on the network. In this section, we're going to discuss application migration. We're going to start off with some considerations for application migration. As a Google Cloud customer migrating to the cloud, one of the things that might be worth considering is the merit of working with a partner. Working with a partner enables you to learn from the partner's experiences, which hopefully should mitigate risk. As previously mentioned, it is highly recommended to keep the migration process simple. Where possible, start with a lift and shift migration strategy and move to more advanced migration strategies over time. Configuring the landing zone, in other words, the destination for the migrated workloads, to be identical to the source environment can significantly simplify the migration process. Where possible, reduce your administrative burden by taking advantage of managed services. And in some instances, especially for very simple workloads, it may be feasible to simply import the on-premises virtual machine image as a migration strategy. Also consider whether it's feasible to make use of two environments, for example, where one of those environments acts as a backup to the other environment. Some global customers invest in multiple environments as a disaster recovery strategy, and this can sometimes make for a good cutover for migration. And in some instances, a backup of the source environment can be used to migrate the workload to the destination environment. Let's consider some of the activities you may wish to perform prior to migration. Prior to migration, it is important to identify and prioritize the workloads that can be migrated. It is also advisable to map workloads to cloud services. Where feasible, create a landing zone or a foundation in the cloud that closely mimics the source environment. It is also important to determine the network configuration in advance and ensure there's connectivity between the source and the destination environment. In order to secure your workloads and applications, it is important to define roles and enforce identity and access management policies prior to migration. Many cloud customers begin their migration journey to the cloud using a lift and shift strategy. And in most instances, the migrated VM uses a public image from Google's public catalog. Directly importing an image is also an option where the virtual machine requires an image that's not available in the public image catalog. And where the effort required to migrate a VM to a public image is significant, it may be feasible and even recommended to simply import the original boot disk image. This concludes our discussion on migration. The migration journey doesn't end here. In the next section, we're going to explore the optimize phase.